My name is Dr. Garcia Estrada. This is problem 5 of Homework 1 of the Probability and Stochastic Processes class at the NYU Poly. So for this problem, a diagnosis test has to be applied to 100 patients. The probability of positive of such test is 0.1, and two techniques are being discussed. Technique 1 is to get all 100 samples and test all of them. And technique B is divide the samples into groups and mix the blood, and if a group tests positive, then each individual of that group is going to be tested. So first we're going to define the number of tests that need to be applied for each group. We're going to have that if the group tests positive, then the total number of samples is going to be equal to 11. And if such group tests negative, then the number of total samples for that group is going to be equal to 1. Now, the average numbers of tests per group is going to be defined by the next equation. The average tests are going to be equal to the numbers of tests when negative times the probability of negative to the m, where m is the total number of groups. Plus number of tests is positive times 1 minus the probability of a bar to the m. So applying 10 tests, this is going to be equal to 1 times 0.9 to the 10 plus 11 times 1 minus 0.9 to the 10. Now solving this equation, we get that the average number of tests for each group is going to be equal to 7.513. Now, to get the average number of tests for all 10 groups, we multiply this by 10. Then average groups, this is approximately 75. And now to get the amount of tests that are going to be saved using this technique, we just subtract 75 from 100, and we get that 25 tests are saved. This kind of approach is interesting in the sense that whenever there are not enough amount of tests available, this could apply. In theory, this could have been one of the solutions that could be used when there was a shortage of tests due to COVID.